Okay, so Chapter 7 review. For domain, remember that there are 3 basic rules for domain. If it's a polynomial, then it is negative infinity to infinity. No work required there. Second, if it is a square root, then you set the radicand to be greater than or equal to 0. And the third rule is if it is a rational, which means a fractional function, a function with a fraction, sorry, then you set the denominator not equal to 0. Okay, so those are our 3 rules. All right, so number 1. So number 1, you can see as a polynomial. And so our rules for polynomials is that it's defined everywhere. So negative infinity to positive infinity. Okay, so this is a perfect example of a polynomial. All right, number 2, this is a square root. And so the radicand, which is 6x plus 15, must be greater than or equal to 0. So subtract 15 and divide by 6. This does reduce. This is a fraction that can reduce. Divide both top and bottom by 3. So you get negative 5/2. So how I write this is the answer in inequality form. I want it in interval form, so since I can't equal, I'm going to use a bracket. And I go on to infinity. Number 3, I've got, this is a rational. So how we did this in class is we would say if you look at the top, x minus 1, that has no restriction. 5x plus 12 would have no restriction except for the fact that it's in the denominator. So we say 5x plus 12 cannot equal 0. Subtract 12 and divide by 5. So keep in mind what this is saying is choose any number except this number. So you can be lower and you can be higher. So that's the union. Negative infinity to negative 12/5. Don't touch it. Skip it and then go on. Okay, and lastly, number 4 is kind of tricky. If you want to rewrite it, first of all, as square root of 1 over square root of x minus 4. When you have a big square root, that's what that means. Furthermore, I know the square root of 1 is just 1, so I can do that as well. So now I see on top is just a number. That's not going to cause a restriction. On bottom, I have a square root. And so typically I say square roots have to be greater than or equal to 0. But then because it's in the bottom, it can't equal 0. If you combine these 2 statements into one, at first you say greater than or equal to, and then you say not equal to. So basically what I'm having to do here is I'm saying, well, greater than or equal to is not okay. I'm going to take away this or equal to. Not equal, right? Because that's what that says. So now I have x minus 4 has to be greater than 0. Add 4, x has to be greater than 4. So 4 to infinity. Okay. All right. Number 5, when you see the graphs, it is asking you for both domain and range. So domain, if you start on the left, you've got an arrow, everything's okay. Move up to the right, or move to the right. You notice you really can't go on. The only way you can go on is if you pick up your pen. If you pick up your pen and put it back down, that's a union. And so what x value, domain is x values, what x value you're skipping is right here at -1. So negative infinity to -1, union, -1 to positive infinity. So same idea for range. Start at the bottom, everything's okay. As I move to the top, everything's okay, except I'm going to be stuck at this level, this y level right here. The only way I can keep going is if I pick up my pen and go back. So I'm skipping the y value of 3. So negative infinity to 3 and 3 to infinity. Number 6, domain left, all good. I can go to the right and I never pick up my pen. Now my range, my bottom, doesn't start till here. So that's a y value of -3. But if I move to the top, everything's good. I got an arrow. So I can go on. Alright, number 7, f of x plus 1. So I'm going to use my f. I'm going to plug in x plus 1 here and here. So x plus 1 squared minus 10 x plus 1 plus 7. Okay, if you FOIL this, so that means x plus 1 times x plus 1, you get x squared. So you can do that on your own if you want. Plus 2x plus 1 minus 10x minus 10 plus 7. So for a final answer of x squared minus 8x, -9 plus 7 is minus 2. G of -4. So if I plug in -4 for my G, -4 cubed minus 4. It's good practice to put these things in parentheses. So -4 cubed is negative. It is negative 64 plus 16 minus 13. So -64 plus 16 is -48. Minus 13 is -61. F of 2. So 2 squared minus 10 times 2 plus 7 is 4 minus 20 plus 7. 4 minus 20 is -16 plus 7. -16 plus 7 is -9. G of A. So really this is just saying use A instead of X. A cubed minus 4A minus 13. If you want to put those in parentheses, you can. It doesn't really make a difference. Alright, number 11, X, Y. So I want, this is the one I'm doing right now. I'm going to start at 3, and I'm going to use a closed circle here, because it's or equal to 3. So then I'm going to go down. So 2, 1, 0, -1. That should probably be good. So if I plug in 3, I get 3 minus 1 is 2, squared is 4, plus 6 is 10. So that's 3 comma 10. 2 minus 1 is 1, squared is 1, plus 6 is 7. Plus 6 is 6, so you can do this. Alright, so 310. Well, let's go ahead and get this one. This is hard on a computer. X, Y. So 3. But this one, because I cannot actually equal 3, I'm going to use an open circle here. And then I'm going to go to 4, because I want to be greater. 5, 6, that's probably good. 4 minus 3 is 1. 4 minus 4 is 0. 4 minus 5 is -1, -2, so forth. Alright, so I'm going to graph I'll graph my black and black, my red and red. So 310. And that was with a closed circle. 27, 9, 8, 7, 1, 6, 0, 7, negative 1, 10. So you can see the symmetry. Okay, and remember this point right here, this is where we stopped. We don't want to go any past that, but then I can go in the x direction this way forever. So that's going to be the direction of my arrow. You should always have one arrow pointed left. So this is my left arrow. In red, you'll see my right arrow because that was all the x's greater than 3, meaning all the x's greater than 3. So this will have my right arrow because it's a greater than. Look at that. It kind of, the greater than is a right arrow, right? If you just kind of make that an arrow, it is a right arrow. So that's where your right arrow is going to come from. This is where your left arrow is going to come from. This one has the closed circle because it's or equal to, and this one won't. So anyway, so in red, I've got 3, 1, and make that a very obvious open circle. Sorry, that's not very good. That's supposed to be 3, 1. 1, 2, 3. I did it again. If I do it a third time, though, I'm just gonna have to deal with it. 1, 2, 3, 1. 4, 0, 5, negative 1. Okay, and it's gonna go forever that way. So, big picture, this is what it looks like. So again, grading wise, we have to see this arrow. We have to see this shape. We have to see this is a closed dot and it stops right here because that's saying don't go past 3 for my black dots because that was this equation that says x is less than or equal to 3. And then in red, I have this open circle. I have a line down because this is a linear function and a right arrow. Okay? All right. 12. 12 is a pretty hard question because it's got some ugly numbers here, but if you really can do fractions, it's not too bad. So you want to be perpendicular and you want to be bisector. So let's take care of the word perpendicular. Well, first I have to figure out what the original slope is. So y2, 5 minus 2 is 3, and negative 1 minus 6 is negative 7. But I don't want the original slope, I want a perpendicular slope. So that's going to be positive 7/3. So this is taking care of the word perpendicular right here. Okay? Now I got to take care of the word bisector. So I just think of these as two separate words. They cause two separate things. Bisector means find the middle. So the middle is add and divide by 2. 6 plus negative 1 is 5 divided by 2 is 5/2. And 2 plus 5 is 7 divided by 2. So my midpoint is at 5/2 and 7/2. So now I officially have a point I want to pass through and the slope I want to use. Point slope formula, which is y minus y1 equals m x minus x1. So y minus 7/2 equals m, which is 7/3. That's my dogs. Of course, I make one mistake. All right, I'm just going to have to x minus x1 is 5/2. Okay, distribute. So 7/3 times x is just 7/3 x. So y minus 7/2 equals 7/3 x. And then 7/3 times negative 5/2 is going to be minus. So 7 times 5 is 35. And 3 times 2 is 6. Okay, add 7 halves. Add 7 halves. I need a common denominator. So this has a denominator of 6. I'll multiply 3 over 3. So I'm just going to put it up here. Plus 21 over 6. Because if I do 3 over 3, 7 times 3 is 21. Alright, so final answer. Y equals 7/3 x. Negative 35 plus 21 is negative 14 over 6. I guess I spoke too soon. 14 over 6 does reduce. So, final answer. They both divide by 2, so that's going to be 7 over 3. So y equals 7 over 3x minus 7 over 3, which is kind of weird that happened. Totally coincidental. But this is the final answer. Alright. 13 and 14, these do not get any easier. Vertical line is vux, so it's x equals, and then your x value is 4. Horizontal line is hoi, so it's y equals, your y value is 1. Okay, 15, you want to go midpoint of AB, so that's right here, and through C, so y equals mx plus b, your slope, if you count from one point to the next, is negative 5. So negative 5x, and then your y-intercept, where does it cross the y-axis? Right here at 0, plus 0. I would just write that. Line through A and perpendicular to BC. Well, first, what is the slope of BC? So I go rise 6, run 1. So 6 over 1. So a perpendicular slope would be negative 1/6. And I want to go through the point negative 2, 1. So y minus negative 1 equals negative 1/6. X plus 2 minus negative 2. Y plus 1 equals negative 1/6 x minus 1/3. I reduce 2 over 6. Y equals, subtract 1 minus 4/3. Alright, I'm not going to write all this, so if you want to listen, this is vertical compression, this is left 1, down 7. Okay, number 18, the negative makes you reflect, the 3 makes you vertically stretch, right 2, up 4. Alright, 19, completing the square, so y equals, there's nothing to pull out here, x squared minus 6x plus blank, I forgot my blank, minus 14 plus blank. So, half of negative 6 is negative 3, squared is 9. To compensate positive 9, I have to subtract 9. X minus 3 squared minus 23. Okay? Discriminant. That was b squared minus 4ac. So go back to the original. B is negative 6. I got to square that. Minus 4ac. You know what? I'm not even going to do this math. This is a positive. Minus negative is plus. That's greater than 0. Therefore, 2 real solutions. Alright, 23. X squared minus 4x plus blank plus 10 plus blank. 3. This is 4, that's 12, so subtract. So x minus 2 squared minus 2. Alright, b squared minus 4ac, so negative 12 squared minus 4ac. So this isn't quite as obvious, so I'll have to do a little bit of this. 12 squared is 144. It's positive because you square that negative. 4 times 3 is 12, times 10 is 120. So now I can see that's still going to be greater than 0, so 2 real solutions. x plus 2 squared minus 1 minus 4. So this is again too real. Alright, f plus g is 3x squared plus x squared is 4x squared minus 9. It does state the domain, or say to state the domain, so that's negative infinity to infinity. So it's just a polynomial. F minus g. So 3x squared minus x squared is 2x squared. Negative 5 minus negative 4. And so negative 5 plus 4 is minus 1. This is, again, all real numbers. F times h. So this is f. If I multiply, I can show this one. So let me zoom in. So 3x squared minus 5 is my f. And I'm supposed to multiply times 1 over 2x minus 5. Anytime I have fractions, I go ahead and make them all. So that's 3x squared minus 5 over 2x minus 5. This does not reduce, so that's as far as it's going to go. And then the domain, this is the only thing that's going to cause a restriction, can't be 0. So that's going to be negative infinity to 5 halves, and then 5 halves to positive infinity. Because right here you're getting x cannot equal 5 halves. G over h. I'll have to explain this one in class, it's too much. Alright, f of g. So my inside is g of x, so that's x minus 7. So now I'm going to plug this in right here. So now I'm doing f of x minus 7. So instead of using just an x, right here, instead of just an x, I have x minus 7. So instead of this x, I'm going to have x minus 7. So that's 3x minus 21 plus 1 is 3x minus 20. Okay, other way, you're going to get, so you can try to do this one, and you should have gotten 3x plus 1 and under the square root minus 7, which does not reduce. 28, this is just going to be a minus 7. 29, 3x squared plus 16 is under the radical. 30, g of 10, if you plug in 10 for your g function, you get 3. Now I'm going to do f of 3. So 3 times 3 is 9, plus 1 is 10. Square root of 10 does not reduce. F of 8, so that's 3 times 8 is 24, plus 1 is 25. Square root of 25 is 5. 5 minus 7 is negative 2.